So let us start the final topic, that is RSA algorithm. RSA algorithm named after three cryptographers who developed this algorithm in 1978. The first cryptographer was him, Ren Rivest, and the R they have considered from this, and Adi Shamir S they have considered from this, and Leonard Adleman A they have considered. So RSA algorithm. Okay, this RSA algorithm has following steps. First one, key generation. In key generation, we have 7 steps. One by one, we will look into it. So first step says select two large prime numbers P and Q. Second step, the multiplication of those two prime numbers, okay, P into Q. Name it as N. Third step, we will calculate the Euler's Totient function that we represent by phi of n. How do we calculate that? By multiplying p minus 1 and q minus 1. Okay, phi of n is equal to p minus 1 into q minus 1. That will give us the Euler's Totient function. That is the third step. Fourth step is to choose the value of E. Okay, we have to choose the value of E in such a way that it must be greater than 1. It must be greater than 1 and lesser than phi of n. What is phi of n? Phi of n is Euler's Totient function. Okay. Then calculate the value of D using D is equal to e power minus 1 mod phi of n. This also can be written as E into D is equal to mod phi of n. Then next step is public key. Public key we will find out by plugging the values of E and N. And then we private key find out by plugging the values of D and N. D value we will get from here. N value we will get from second step. N value we will get from second step. D value we will get from step 5. E value we will calculate from step 4. Then there is something called encryption. Encryption we will find out by using the formula C is equal to m power E mod n. M value will be given in the question, that is known as plain text. C value we will find out, that we call it as ciphertext. C value we will calculate by plugging these values, M value, E value, N value. Then the final step is decryption. Decryption we denote by capital M is equal to C power D mod N. C value we will get from encryption. C value we will get from encryption. D value we already have found out in the above steps. N value from second step. First problem is using RSA algorithm find public key and private key with respect to P is equal to 3, Q is equal to 11 and M is equal to 31. To find out public key, we should know how to represent that. Okay, then private key, how do we represent those? Public key we represent by E comma N. Private key we represent by D comma N. D comma N. Then let us write the given part in the solution. P is given as 3, Q is given as 11. These are the two prime numbers they have given. Then we will find out the value of N. How do we find out the value of N? By multiplying P and Q. P into Q is equal to 3 into 11, that is equal to 33. So first, this is our first step, choosing the values. This is our second step, finding out the value of n. This is our third step, that where we will calculate the totient Euler's totient function that we represent by phi of n. How do we find out that? P minus 1 into q minus 1. P value is 3, 3 minus 1 is 2, q value is 11, 11 minus 1 is 10, 10 to the 20. So phi of n value we have got as 20. Now, as I told, phi of n, we have got how much? 20. And we should select the value of e such that this value of e must be between 1 and phi of n. Here 1 we have, e value we will write, phi of n is 20 we have. So in this problem, we have selected the value of e as 7, which is obviously greater than 1 and less than 7. It is not necessary that you have to select e value as 7 only. You have to choose any value such that the GCD of that value with respect to the phi of n, that is 20, should be equal to 1. So if you suppose if you are considering e value as 3, suppose if you are considering e value as 3, the GCD of 3 comma 20 must be 1. That you have to look after. If this is not satisfying, so e value is wrong. So be careful while selecting the value of e. Then you have to find out the value of d. How do we find the value of d? By using the formula d is equal to E inverse mod phi of n. As I told, we can write this part as this d into E congruent to 1 mod phi of n. All values we know except d. E value we know it is 7. D is unknown, congruent to 1 mod phi of n. Phi of n is 20. Therefore, we'll get how much here? 7d congruent to 1 mod 20. If you calculate by using Euclid's algorithm, if we solve this, we'll get d is equal to 3. It is just like we have solved already, congruent 7x congruent to 1 mod 20. Okay, for which value of this one we can write as 20 by 7x minus 1. Okay, this we can write as 20k is equal to 7x minus 1. So you have to choose the value of x such that it should be a multiple of 20. So for x is equal to 3, how much you'll get? 7 3s are 21 minus 1, that is 20, which is a multiple of 20. Therefore, this x is equal to 3 is true. In this congruent, x was the variable. Right now we have d as the variable. So for the value of d is equal to 3, this congruent is true. So therefore the value of d is equal to 3 is correct. Then we will find out public key and private key. For public key, we mention e comma n. E value we know, n value we know. E value is 7, n value is 33. Then find out private key d comma n. D is 3, n is 33. Then find out encryption. Encryption we will find out by c is equal to m power e mod n. Okay, all values we know now. M value, capital M, they have given us 31. E value is 7. Mod n value is 33. So 31, C value, this congruent we have got. Okay, Now we have to find out the value of 31 power 7, 31 power 7 mod 33. How do we find out these values? Since this is a large number, take out the base to the power 1 itself. So 31 to the power 1 is congruent to, here you have mod 33. Okay, since this is a smaller number than 33, we can make use of addition modulo and write the remainder as -2. If you are writing -2, that means what? 32. If you take that -2 on the left hand side, it will be 31 plus 32, 31 plus 2, that is 33. Obviously, we'll get what? 0 mod 33. So, which is satisfying. Therefore, addition modulo, if we are using, we can write this as true. So, 31 congruent -2 mod 33 is true. Here we have mentioned in this step 31 congruent to -2 mod 33. Now we want 31 to the power 7. So raising 7 both sides. So 31 to the power 7 congruent to -2 whole to the power 7 mod 33. 31 to the power 7 congruent to -128 mod 33. Then if you reduce this remainder 128, you'll get -4. How? Here you have -128. This 128 can be reduced still by using division. So 128 you divide by 33. 33 fours are, you will get 132. Okay, you will get -4 as the remainder. That can be substituted here. This minus side is outside. This value, this remainder can be written as -4. Okay, 31 to the power 7 congruent to minus of minus plus 4 mod 33. So once you are getting this value, then you write the values of then you write A, B, C, D, E, F just like this. And starting from 0, you mark the values 0, 1, 2, 3, 4 and so on up to 26. So now you have 4 means 0, 4. 0 stands for A. 4 stands for E. So this is your encryption. So C is equal to AE. Finally, M value, capital M is equal to 31 they have given in the question. 3 stands for D and 1 stands for B. Okay, as I told, capital M represents the plain text and this small c, this capital C, that is equal to 04, which we have written as AE, represents ciphertext. Then the last part is decryption part. We will calculate by using capital M is equal to C power D mod N. All values we know now. Okay, C value we know it is 4, D value is 3, N value is 33. So 4 cube is 64 mod 33. This remainder still can be reduced. So you have 64 here, 33, 33, 1s are 33. Remaining is 31. So that has been replaced here as a remainder. So capital M is equal congruent to 31 mod 33. Therefore, capital M is equal to 31, which was also given in the question. So it has been verified now. So that is equal to capital 3 stands for D, 1 stands for B. Hence the solution. Till here you can do that part. Let's discuss the second question. We have in RSA algorithm, if the value of P is equal to 7, Q is equal to 11 and E is equal to 13, then what will be the value of D? So till you find out the D value, you have to follow the procedure. First step, P is equal to 7 given, Q is equal to 11. Find out N, P into Q, that is 7 into 11 equal to 77. Then you find out phi of N, P minus 1 into Q minus 1. P is 7, 7 minus 1 is 6. And you have 11 minus 1 is 10. 6 into 10, 60 you have. Then choose the value of E such that it should be between 1 and 60. So here it has been chosen 13. Okay, such that the GCD of 13 and 60 is 1. Now to find out the value of D, we have the formula, that is D is equal to E inverse mod phi of N. All values you know except the value of D. So E value is 13, D as it is congruent to 1 mod 60, phi of N is 60. So here as usual, as I told, solving for X, here solve for D. Find the value of D such that this congruent holds. So here D is equal to 37 will hold the congruence. Then after finding out the D value, if they are asking for public key and private key, write this part. If they are asking public key, E comma N. E value is 13, N is 77. Private key if they are asking, D comma N. D value is 37, comma N value is 77. Stop there.